Welcome everybody. Again, my name is Michael. I am the CAM training and sales specialist for VHF. Today, we are going to take you through 5 reasons to consider a VHF mill. And these are really good topics that come up quite a bit when considering different dental mills and packages and so forth. So let's go ahead and jump into these and get started. So 5 reasons why VHF. So I'm just going to list through these real quick, and then we're going to dive into each one of these topics a little bit deeper throughout the presentation. But the main reasons are it's a trusted open system that works with all scanners, design softwares, and open materials. It also gives you maximum freedom regarding the material and sizes for disc blocks and prefab abutments. Again, industrial quality, which means reliability, precision, and speed. So we're going to talk about precision and speed and how our units and our systems provide that for you. We're going to talk how to take advantage of support and training and what it looks like through our resellers and our company. And then we're going to talk about the VHF environment and why is it important and how it works together. So these are some really good topics. Hopefully we'll answer a lot of your questions. As you heard before, we will have a question session for you at the end of the presentation. Depending on time, we might stop and take a few questions during it as well at different points along the way. We'll just have to see how we're going through the presentation. But definitely, any questions on any topics, please submit those through your, I think it's the questions and answer box, and we'll be happy to answer those for you. I'd like to start out with a little overview of VHF, just to give you a little history of the company itself. As you can see, we've been in business for over 30 years. We are located, our headquarters are in Ammermuth, Germany. It's about a little bit below Stuttgart, Germany, down in the Black Forest area in the corner of the country, as you can see there. And we are currently over 300 employees and growing. So we have a lot of experience and a lot of history in the industrial and dental CNC area. Just a little look at our campus. We are up to 9 buildings and growing. We have a very state-of-the-art high-tech campus. The picture you're seeing on the screen there is actually on the right is our administrative offices and conference. On the left is actually production. That's where they actually hand assemble every one of these machines to order, as well as training and conference rooms and in the building on the left there. That little corrugated wall right there in the middle is actually where all of the machines are, like I said, hand assembled. A little bit about the lineup of our mills. So we're going to be talking about why VHF mills. It's nice to know what mills you can be looking at through the Zahn portfolio. We have 3 different mills in this lineup. We're going to start by talking about the R5 mill real quick. The R5 is our gold standard mill. This is for labs or practice labs that do not want to compromise. They want to be able to do anything. This is a 5-axis mill. It is a automated mill. It can hold up to 10 discs or 60 blocks or 60 abutments. It can hold any material in 98 millimeter disc form up to 40 millimeters thick. That's great for your dentures and your denture bases. Gives you the ability to even do the larger uppers. It is a wet and dry mill. It automatically switches from wet to dry on its own. So you can do your titanium abutments as well as titanium bars with this mill, even down to your same day crowns. So this mill is going to give you the full spectrum of indications and materials. The S5, this is a great mill for labs and even practice labs that want to get into the automation. So this mill is a dry mill out of the box. It is 5-axis. It can do all the materials in 98 millimeter form up to 30 millimeters thick, so still a pretty good thickness and puck. It can hold 24 blocks or 24 abutments. It has an 8-disc changer in it as well, so it does give you that automation. One thing that's really nice about this, PMMA, zirconia, really good workhorse for those. But this also has an option to add on a wet kit. This is a great affordable option for somebody that wants to get into the automation and still be able to produce. And maybe right away, there is not a real need to get into either titanium abutments or the glass ceramics like the wet milling of Emax and so forth, but they plan on wanting to get into that down the road. They can start out with the S5, and whether you purchase the wet kit at the purchase of the machine or later on, it's pretty much the same cost. And then adding on that wet kit will allow you to process all materials at that point, including your titaniums and your glass ceramics. So again, this is a great option, again, for your dentures, your full arches, zirconia, even down to your same day pieces as well. But then again, gives you that flexibility to bring in that wet if needed at a little bit lower initial investment costs. K5 Plus, that's a pure power horse over there. This is actually a small footprint mill. It's a 200-pound mill, very sturdy, very robust. It is 5-axis as well. This one can hold up to the 40-millimeter pucks, and it is a single puck mill, but it is still a great option for a lot of places that want to bring in the ability to do the puck milling. They're doing a lot of maybe all-on-4 zirconia, dentures. Again, you can do the thicker ones with the 40-millimeter holds. It is a dry-only mill, so you will not be processing glass ceramics or titanium abutments on it. It doesn't require tools to load or unload the pucks. You simply open the door, flip 2 levers up, the door opens, you take the puck out, put another one in, close the door, and lock it down. A lot of the indication types that will probably be running in this mill are going to be your longer runs, your full arches, your dentures, maybe full zirconia discs full of crowns, things like that. So there's not a need to be in front of it every few minutes. So not having a changer in this case is not actually a real downfall. And it is a little bit more cost effective as well to bring that in and still get that great speed, efficiency, and power out of the mill. So I just wanted to give you a little overview of the mills that we're going to be talking about through different topics as we go forward with the discussion on 5 reasons to consider a VHF system. Again, anytime during the presentation you have a question, type it in. Like I said, when we get time for questions, we'll be happy to answer this for you. It could be on anything, mills, topics, we're covering anything you want. So the first topic, open system versus closed systems. So the VHF products are an open system. When we talk about open system, what does that mean? That means that we can work with any scanner and design software that can output an open STL file. So if they can save the design out of the restoration out of the design software as an STL file, we can bring it into our CAM and nest it inside of our system. So it really opens up flexibility. As you can see, it makes this ability to work with all scanners and design softwares pretty much out there. Like I said, all they have to be able to do is after they've designed the piece, save it out as a STL file, and then we can bring it in and run with it. We get a lot of questions on that side of it, where do you work with this scanner? Do you work with that scanner? It's not the scanner that's the important part when it comes to the milling, it's the design software. You want to make sure you have a design software, obviously, that works with your scanner. And then as long as that design, after you've designed the crown, abutment, or whatever type of indication you're doing, you just save that out as an STL file, open it up inside of our dental cam software. You can nest it and send it over to the mill. So again, it allows you the freedom to work with, maybe you've already got another system in place. Maybe there's other mills that you're currently running and you're using a scanner and a design software for those. And you do have that ability to output an STL file of the design piece. And your current mill doesn't have the capabilities of running that type of restoration. You can simply add on one of our products to that existing workflow and continue with that line of work. Another thing people don't think about is the ability, maybe you just have a scanner, maybe you don't have the capability in your design software currently to do a certain restoration type. You can scan, send out the design to one of these design centers, let them design that restoration or indication for you, send you back the STL file. You can then bring that back into our nesting software, nest on the mills, and send it over to be run. So if I'm a lab and I'm running one of our open systems, it really opens me up to be able to work with any practice out there that can send me a file. Sometimes with the closed system sides, which we're going to talk about in a minute, it limits what files I can work with. And it's a future-proof system if you look at it this way, you know, the ability to grow and expand with technology. Maybe I want to add a new scanner or an update, new technology of a scanner comes out with my system. I can add that to my package without having to change all the components and put a complete new system in it. And again, some of the downfalls of a closed system, some closed systems are really good, but they force you to use the specific equipment. Again, they're limited to the materials. Expansion is limited to just what can be brought into that system. And there's usually a higher cost with this as well. You're buying a complete package. You can't piece it together with individual pieces. Maybe you have some of them. It's just an overall higher cost usually with it. And then trying to stay up with new technology may be difficult because you might not be able to pair that new technology with your current system. So just some different things to think about between the open systems and the closed systems. Both of them are really good. It's just where are you looking to go? The open system opens a lot more doors for you, gives you the ability, a lot more flexibility, ability to grow, ability to look at different areas as well. And really, it's really nice to be able to work with any practice out there. Again, if you're a lab or wanting to send out files and quickly get something done that maybe you couldn't do in your lab before because it's not in your design software, I can send it out, get it designed, bring it back, and still mill it and not miss a beat. So just some things to think about between open and closed systems. So understanding materials that can work with our system. So again, being an open system, that goes to the materials as well. You know, if you think about our R5 mill, for instance, our gold standard mill, like I was saying earlier when we were discussing it, it can work with pretty much any material in 98 millimeter disc format up to 40 millimeters thick, including cobalt chrome and titanium. It can also work with any block using the Ceric or universal mandrel up to 45 millimeters long. So that's a big, huge open area there as well. And then even your abutments, I think we're, as it states there, more than 800 Ti cobalt chrome prefab abutments available from a wide range of manufacturers and holder systems to hold the blanks like Medentica, DES, NT Trading, those areas as well. Really easy option to nest and mill on titanium abutments in these mills that can handle the wet options. Again, that thicker disc gives you the ability to do your larger dentures. Again, remember the upper ones, their average heights are about 36 millimeters on some of the upper taller reach ones. So having the ability to load a 40 millimeter thick puck gives you some really nice options inside of the mill. And again, if you think about it, like we've got there in a number 3, pretty much any indication is possible, depending on the mills. You know, the K5 Plus is going to be a dry only mill. So pretty much any indication in the dry category up to 40 millimeter thick, your dentures, your full arch zirconia, you're all on 4s, all on X, I should say, be a little bit more accurate for those. It's a great option for you there. But just that freedom of not being tied to a specific material and only having a small group of materials. Maybe a new technology and material comes out on the market and you want to try it and run it. We more than likely already have it in our system. And if we don't, we even have generic strategies in our system. There's so many manufacturers of zirconia out on the market. We have a lot of the manufacturers listed directly inside of our material choice in our CAM software. But it's hard to cover all of them because, like I said, there's so many of them out there. So we have some generic strategies. If you buy a material disc of zirconia that's not in our list, you run either the zirconia or the translucent zirconia strategy, and you'll probably be fine with it. And it should cut it no problem. So not only do we have the specific vast majority of manufacturers listed, we have a lot of generic strategies like PMMAs and things like that. We have strategies for PMMA to allow you to run the materials that are lower melting points. So a standard strategy or a material might be running it and melting it a little bit inside our software. We have generic strategies for PMMA burn, which runs a little bit easier and softer. So again, opening up that freedom, allowing you to work with whatever manufacturer of material that you want to use inside the machines. Precision and speed. So we went through the first two kind of quick. We're going to be touching back on those as we move forward here. This section, there's a lot to talk about. We're actually going to be also talking about how the first two also help us in this area also. So what you're seeing right off the bat on the right is a few pictures there. Those pictures, I put these in to help you realize how we achieve speed, reliability, and accuracy with our mills and software. So the first picture you're seeing there in the top left, that's actually the chassis of our S5 mill. All of our mills are unibody, one-piece cast aluminum chassis construction. That's what gives them their rigidity. That's what gives them their reliability and accuracy. The little picture you're seeing up to the right of the motor and the ball screw, you notice the components like the bearing housing connected to that motor where it mounts. It's not flimsy. It's a thick aluminum bracket. Everything is high quality pieces, no knockoff parts. VHF, as you saw earlier on when we were talking about the company, has over 30 years in industrial machine manufacturing. And what I mean by that is they started out building industrial milling machines, and we still do over in Europe. They're just not sold in North America at this time. So we've taken that same structure and quality from those mills and implemented them into the desktop type mill. So you're getting industrial build and quality in a small footprint. You know, a 5-axis mill is a 5-axis mill, whether it's an dental or industrial side of it. And taking things learned from that, like taking those heavy duty industrial pieces and bolting them to a one-piece chassis is going to eliminate vibration and movement, thus eliminating the need for calibrations. When our mills are brought out and installed and set up, there's no calibrations needed. You don't have to calibrate it every 6 months. You don't have to calibrate it year after year. You know, there are calibration settings in the mill, but just like an industrial mill, you only go into those if something pretty big happens and causes those heavy components to have moved, because all the calibration is, when you think about it, is a mask. And what happens is if you take a frame of a mill maybe that has components that are bolted together, over time those connection points will start to wear and you'll see movement. Well, every time that moves, or a piece has the ability to move, which is picking it up and setting it down, you have to readjust where the actual hard components are to a true axis alignment. So you have to go in and recalibrate it. But if things are not moving and things aren't given the chance to move freely, there's no need for having to recalibrate. So that's a huge thing. It's also going to ensure very highly accurate machining. 3 microns repeatability across the board on all of our mills. The ability to reduce the vibrations is going to allow us to hold that accuracy and run really good speeds and times on our mills. It's also, if you think about it, giving you the ability not just to get that same good high quality piece the first time, you'll get that same good high quality piece 6 months from now, a year from now. So having the ability to bring a piece out, look at it and go, wow, that's a really nice finish. I like what I'm getting out of the mill, and know that's what the next piece is going to be like. The next piece is going to be like. As long as you're doing proper maintenance and taking care of your equipment like you should with any mill, these things will last a long time. Also notice, you know, like our spindles, they're German manufactured spindles specifically for VHF. You see how we kind of really overbuild our mills. We do the same with our spindles. And then our software strategies, like our dental cam, never take the machine to its limits. So we kind of over engineer the components of the mill, and we push them hard, but we never push them to their limits. So that way, if you take something that's not being pushed to its mechanical limits day after day, it's going to last a long time. We like to describe it as, think of a truck, pickup truck. You know, you have a 1-ton pickup truck, one of the heavy duty trucks. And if all you're doing is throwing your rakes and lawn equipment in the back of it, you're never going to wear the thing out. It's as long as you maintain it, it's going to be a good, reliable truck for year after year after year. Same things with our mills. If you're using them to the specifications that they're designed for, and you're taking care of them under required maintenance tasks, which are extremely easy on these mills, they will last you a long time and give you repeated, accurate results over and over. A couple other areas, you can see the third picture there is our dental cam software. That's our dental cam 8. A couple features of it. We have what's called direct mill. Direct mill, what that means is you get done with your nest, you hit calculate. As soon as the first packet of information is calculated and sent over to the milling machine, if the mill's ready to go, you can start that job. You don't have to wait for the entire job to calculate. That could save a lot of time. Could save you 20, 30, 40 minutes in some cases, depending on what needs to be calculated. It'll calculate and mill at the same time. So having the ability to just do a nest, hit calculate, get it over to the mill, and start running, that's a big time saver. That's speed. You got to consider that as speed because it's taking time off of the whole process. The picture right below that, what that is showing, sorry, at the beginning of this year, we released our new Dental Cam 8 software, and our development, we actually create the software ourselves, which we're going to talk a little bit more about coming up here later on. We create the strategies and the software in-house. So we were able to release our new Dental Cam 8 software earlier this year, and we've seen reductions in milling times up to 30%, depending on the indication and material types. So again, we're talking speed. Everybody wants to mill things faster, but you also got to think, I need to keep the accuracy. When pieces come out of our mills, the biggest response I see and hear from people is, wow, they can't believe the finish and quality of the piece that's coming out of the mill. And I've asked people, I said, let's just talk with it about like a single crown. You know, I've seen crowns milled really fast in under 10 minutes, and I've seen the quality of them that come out, and they're okay. But I always ask the person that's working with them, you know, do you have to do any bench work on that after it comes out? Yeah, I might have to spend 10, 15 minutes polishing it and cleaning it up, making it look a little better. I was like, well, what if you could just let that stay in the mill for an extra 10 minutes and take it out and just have to maybe cut the bars off and minimal touch-ups on it and move on to the next step? So whether you're doing it at the bench or you're letting the machine work on that part for you where you're free to go do something else. Again, think of it as your time as well. So if you're spending time at the bench working it, that's still time in the process. We don't want to just focus on the 10 minutes it was in the machine. You want to think about the whole time of that whole workflow of the piece, from when you start designing it till it starts nesting and so forth on out, and bring those times together. I was always taught with CNC machining, if you're doing the work and the machine's not, you're not using the machine to its capabilities. That machine should be able to do the majority of the work for you. And again, getting those high quality results that need minimal polishing out of the mill with still really good machining times and competitive machining times is a really great plus. Again, German reliability and quality. VHF's motto is creating perfection. You know, we could give up a lot of quality and cut a lot of time out of milling. We're not going to do that. We're not going to compromise quality and precision just to give you a super fast time. We want to give you that same high quality results. So, you know, some of the other ways, no tools needed to load or unload your discs. And that goes for all three of the mills, really, that we saw at the beginning of this. The R5 is direct disc. What that means is there's no frames on it. Simply pull a lever back, stick the disc in the mill, and release it, line it up. It's ready to go. No having to sit there and screw frames on your pucks. The K5 Plus, we talked about, it has just a lever, like a lever release system. The lid opens, you put the disc in, you close it, you flip the lever. You can really do it with one hand if you really wanted to. The S5 for your PMA and your zirconia materials has what's called a magnetic frame holder. And you simply just pop the top off, put the puck in, snap it back on, and load it into the mill. And if you think about it, all three of these mills, and you think about your fragile zirconia pucks, that's going to eliminate the possibility of uneven torquing and cracking or breaking or chipping those very fragile pucks. So no tools. To me, that's a big speed factor as well, not having to keep those laying around and looking for them. The R5 is an automation machine. You know, let it run when you're not there. It's a wet and dry mill. It has the ability to switch automatically from wet to dry on the fly unattended. Does a really good job at it. It's built into the construction of the mill on how it does it. The fourth and fifth axis are actually on different axes of rotation to allow it to reach and clean and dry and blow out the entire milling area. It takes about 14, 15 minutes, but you can load up a bunch of zirconia jobs, PMMA jobs, titanium jobs, glass ceramic jobs, hit go, go home. Come in the morning and those jobs will be completed. So that ability to work unattended and not have to stop and switch the mill from a wet process to a dry process, that's speed. The S5 also has the automatic disc changer. So again, you can work with the automation in that one to get some speed in your production. Allow you again to work when you're not there. And you know, a lot of people always, the first thing people think of when they think of parts changers is when they're not there. A lot of people use it and should be using it while they're there. You could come in the morning, load up all, let's say again, the R5, for instance, load up all your jobs for the day and hit go. So you've got all these pucks and the machine is processing the jobs. And as one disc gets completed and gets moved back to the carousel, it grabs the next disc and starts working. You can open the bottom and pull that completed disc out and start processing it. But by loading all the jobs up at the beginning of the day, it's just working away and you're taking the ones out that are done and moving on to the next step of it. So you're not having to stop what you're doing, go back over and start the next job. So just some other ways to think about how you can actually use and process on the mills. They're all speed and precision. These are areas that we like to bring together and have you think about different ways. Again, you can always think about just the time it takes to run that, but also think about the time for the whole workflow inside that area. Another area that's going to save you time is our CAM software itself. It's very easy to use. It's very straightforward, and it has predefined strategies. It kind of like walks you through it. So it's very easy. You choose a material, a size, STL files of that you want to nest. You tell it what it is, the quality you want, position it, set a bar, and move on. So being so easy, you can bring people in that have no experience with it, very quickly teach them how to use the software and get it running through the facility. You should not be spending a lot of time nesting in our software. If you're nesting a single block, it should be about a 5-minute process. The picture of that disc, I would probably spend no more than 10, 15 minutes tops nesting on that to get it over to the mill. So once you become proficient in that software, you'll see it's the nesting part should be really fast and simple. Everybody always gets nervous about working with titanium abutments. The milling side is going to be the easiest part of it. The design is probably the key and the most important. When you get to the nesting, it passes an STL file and a construction file. So when you get into the nesting software, you choose the platform of the holder, for instance, like desks. You choose your STL file of the titanium abutment in this case, and you hit next and it positions it, sets the bar, and all you do is hit calculate. So all that information is coming over from the design software. The nesting software takes care of it, goes to the mill, you mill it and bring it out. So again, the nesting and the milling side of that particular indication type, it'll probably be the fastest one you can do in the workflow system. So precision and speed, industrial quality, industrial build, high quality components, again, a lot of which are made by us off of our industrial machines at our manufacturing facility over in Germany. We actually make a lot of the components that are used in the mill itself. Hand assembled, very accurate, very good speeds, and some other things to think about with it. Training and support. So there's some different areas with this. And what I decided to do with this is, since we are the manufacturer, we don't usually deal directly with end user training and support. You know, we work through a reseller network. We don't sell directly. Is to give you an idea of how your ownership would be of our products working with VHF and our resellers. So in this case, we're going to go with Zahn, obviously, as the reseller. You purchase one of our systems through Zahn. The installation will be done by Zahn or with the help of Zahn. So they will help you get the machine set up and ready to go. They will also provide the training for the products that you purchase. Once you're trained and ready to go, you're off and running. Let's say you have questions or an issue comes up, things like that. You have a lot of options. And there's actually options people don't realize that are out there other than just calling into a support phone number. We have a lot of free resources online that anybody can use, and you can actually find a lot of information on those. One of them is the dental portal, and we're going to talk about this on the next slide as well. But we have a portal. Our dental portal is our technology site. It covers everything there to do is with our dental cam softwares, our tools, our machines, every aspect of the machine, actually from installation to troubleshooting to maintenance to how to use it to technical specs, downloads. You can go up on there and find anything you need to know about any one of our mills on that site. It's a free site, very easy to access. There's even a troubleshooter with an error code chart. So let's say, for instance, you're running a job and you get error code -6 up on the screen. You could go to the troubleshooter list, scroll through the list, find error 6. It'll probably say tool length is out of range, and you can click on that and it brings up an interactive troubleshooter. It'll ask you questions. Are you working with a 4-axis or 5-axis mill? What were you, and it walks you through it. Maybe you can figure out your issue very quickly without having to call into a phone number and move on. If not, and you can't get through it, it tells you to call your support representative at that point. So there's a lot of great resources up online for you to use like that. As well as we have a couple of YouTube channels. When you're looking those up, you want to type in VHF Camfacture. They're under our parent company, which is out of Germany, VHF Camfacture. Our US is VHF Incorporated. We are actually based out of Long Island, New York, which we're going to talk about in a moment. But there is also a second YouTube channel called VHF Camfacture Tutorials. The main Camfacture is a lot of promotional videos, testimonials by KOLs, webinars, things like that. You can go up there and watch those. Maybe you're interested in taking a look at one of our systems. Definitely go up on there and check it out. You'll get a lot of great information. The tutorial channel is going to have a lot of playlists for the different mills, for the CAM softwares, every portion of the CAM software. Maybe you're having a issue with setting a bar on the dental cam 8 on a specific restoration and you want help or information on that. You can go to that and there's a little quick video on how to set bars in the dental cam 8, or you can go to the dental portal and go to the dental cam software, dental cam 8, setting bars, and it gives you what every setting means and where they're at inside the software, and even gives you recommendations on working with zirconia and how to, and bar placement and all of that stuff. So there's so much free information out there that people don't realize. It's a great resource. It's a great place to go to get that information to help you move along without just jumping on the phone and calling your support department. If you do want to jump on the phone and call your support, it is provided by your reseller, first level. So Zahn has a really great support team. We've spent a lot of time working with them, getting them trained. They've been out to our facility directly for training on service and support with the mills, and the software. So they will be a great option and resource for you. Definitely take advantage of that. If they get in trouble, or I shouldn't say in trouble, come across an issue that they're not sure on or they haven't encountered before, they contact our support. We are the second level. We will jump in with them, whether it's remote connection, whatever need be, and help them figure out the issue and get you going. So we do provide second level support to our resellers. We're not going to just leave you out there. We're going to back our resellers as much as we can. The great thing about VHF Incorporated, like I was saying, our US headquarters are located on Long Island in Hauppauge in New York. Back in about 2016, VHF decided they wanted to have a North American presence. So they opened up VHF Incorporated. We have a full service center there. We have inventory for our resellers. We can support them with the sales side, questions, service, and support. So we can back them with support, and we have a full service center there. We can do any repair at our facility in New York that they can at the factory in Germany. So the ability to not have to ship the mill out of the country for worst case issue is huge. The worst case for anybody that buys in the US now is it has to go to New York. Shouldn't have to do that, but if it did, again, it's a lot cheaper to ship to New York than over to Germany to get that mill taken care of, or any other country. So that's a big plus. And again, they're not having to wait for international time zones for help for the support. The way our support works for our resellers, if they call into us, we actually currently have, I think it's 17 hours of support for them. Our German support team in Germany actually speaks English also. So if our phones are off and Germany's phones are on, it will kick them over to them so they can get help there as well. And the goal eventually is to have that 24-hour support. We actually are working and recently have had another office opened up in Shanghai, China. So you have a lot of resources out there for support through the whole process. A lot of people, when they get into these, they're nervous that they're going to buy a machine and then there's going to be nobody there to back them and support them through the process of ownership. Our partnership with Zahn, we are fully integrated with them. You will get installation, training, a lot of resources, and Zahn will definitely have our backing to help you with issues that they might not have come across in the training we've done with them, and then they'll be good for next time. So like I was saying, some of the free resources, the training and support, the dentalportal.info, that's the free website. Go there anytime you want. If you want to go up there now and check it out, it's a free site. Anybody can go there. This picture on the right is the main landing page. You can type in search. There's an interactive, that top left box is an interactive titanium abutment search. So if you're kind of curious what ones we work with and platforms and so forth, you can go in there, type in one, see if it's in the list, all that fun stuff with it. Some quick articles across the top. We have all the information, our Dental Cam 7, 8 machines, best practice resources will take you to the troubleshoot area and downloads of manuals and all kinds of things like that. The Camfacture page, so there's our YouTube page. That's our main one. That's going to be like product overviews, KOL videos, actually some pretty cool stuff. You should check that out as well. And then the Vet VHF dental tutorials down there. Check out playlists. It lists it out by machine or software. A little bit easier than just scrolling through an unorganized list. So go to playlists definitely, and then click on those particular ones. That's a pretty new site. It's only about a year and a half old. And we're growing quickly with the amount of videos. They're constantly getting added into that. On the machine side, if you're curious about a maintenance task like spindle collet maintenance or how to clean the milling chamber, you can go on there and there's specific videos that you can watch on that as well. So some great information there for you also. So the last area we're going to talk about here, and we're doing pretty good on time. We'll go through this and then we'll take some questions at the end. Is the VHF advantage, understanding the VHF environment. Again, VHF is a leading manufacturer of dental milling and grinding machines. What people don't realize a lot is that we actually make the tools and the software as well. Like I've been saying going through this. We've actually been making the tools since the mid-2000s, and we were making for our industrial equipment as well. So we have a really good long history of making good quality tools in the industrial and dental sector. Our tools are heavily inspected, kind of over-inspected and quality checked to make sure their accuracy and quality are top notch. You want to have a good product come out of the mill. It's not just the mill. You got to have really good quality tools, and you have to have really good quality software producing really rock solid state-of-the-art toolpath strategies as well. And you need all of those to work together. So since we're the complete CAM solution provider, is the way we like to think about it, because we're creating the software, the tools, and the machines, and a lot of the electronics that are inside of the mills are also done by us. Like I said, we're a complete facility over there with 9 buildings in the campus and growing. It allows all of these components to optimally harmonize and work together with one single point of contact. So, if you're ownership of the mill and you call into the Zahn support and you're saying, hey, I'm getting chipping on the margin or this and that. Maybe you have a mill and you have a third-party tool and another party made the CAM software. You're going to call the mill company, they'll call in, they're going to look at the mill, and the mill might say, well, no, you need to go look at the CAM software. CAM software might say it's a tool problem. So it's very hard sometimes to troubleshoot those issues. But when it's all coming from one place, they just contact one company. if they're not sure about what the issue is. And it's very easy to troubleshoot, and figure out where the actual issue is coming from in the system. Again, when we design our tools, we're making tools specifically for certain materials and certain machines. We use different tools on our 4-axis machines than we do on our 5-axis machines, pretty much different lengths. When you design a tool, you're designing the geometry of the tool, the flute, rakes, design, shapes, clearances, cutting angles, number of teeth, does it have teeth like the front one there, grinding tool. All that is taken into consideration when designing and creating milling tools. These tools are then specifically designed by us for certain machines and certain materials. Once we have the tools, then we go to the CAM software. We sit down and we write the strategies. The strategies are the tool paths. We write them specifically for different indication types, crowns, all-on-4s, denture base, abutments. You're getting different strategies created. And the way we write those is we write them specifically for that material, for that tool on that machine. So when you have the ability to do that and bring those together and optimize those with some serious testing to ensure that every time you run that piece, you're going to get the same result over and over repetitively out of that mill over the life of it, really goes a long way. Third-party tools, there's a lot of really good tool manufacturers out there, but what could happen is when a different manufacturer designs a tool, they're going to design maybe a different rake to the flutes of it or the cutting edges, a different clearance. Well, when you change those geometries of that tool, you have to change how that tool performs in that tool path. Otherwise, it's not going to cut right. It might be a few microns smaller in diameter. Well, if you just throw it in and run a predefined tool path in our strategies, and we're created for our tools, you could get lines in the part. It could push it too hard. You got to change the speeds and feeds. Chip load, most important thing of the tool is how hard is each tooth of that tool cutting. That's the load of the tool. If you push the tools too hard, maybe a different manufacturer design will be pushed a little softer or a little faster, you're not going to get the same cutting and desired results out of them. Which will end up happening is wearing tools out faster, breaking tools, and possibly wearing out the spindles or the bearings in your spindle because you're putting uneven load on those. Simple little things in tool path designs. When a tool comes into a corner of a part, you have one axis decelerating and another one reaccelerating. And in that corner, there's going to be a little lag as it switches. So that tool is actually cutting across the side of the piece with a little, what we call tool load or deflection. And when it has to stop for a second, it allows it to start catching itself and cutting into the material, and then it changes direction. Sometimes just changing that to a little radius or a swirl, some of them call it like a tricoidal or helical path, will actually allow those tools to cut smoother, more accurate, and last longer, and believe it or not, cut faster. So simple tool path strategy design can go a long way. So we have the ability to control all of that, optimize all that, test it, and ensure you're going to get the same result with what we create over and over out of these machines. So that's the VHF advantage or environment, a complete CAM solution. We're not just giving you a machine and saying, hey, go at it. We're saying, hey, with this software and these tools, you're going to get the optimal performance out of these machines, day after day, month after month, year after year with them, with very easy setup and operation. So think about that as well. Somebody say, well, that's could be a closed system. No, we are still an open system. We work with any design software, any material manufacturer. And actually, our mills can work with a lot of other CAM softwares and tools. You kind of lose the repeatability and the advantage of that reliability out of them. There's softwares out there that allow you to go in and create your own strategies and tool paths and adjust the speeds and feeds. Those are great. A lot of people want that control, but what that does is opens you up for not getting that same quality or that same result over and over out of every piece. If that's something that you want to be able to provide, sometimes having the ability to change a lot of settings isn't always the best option. All right. So another way I want to just discuss this as well You know, when you think about multiple pieces working together, think about a sports car driving in the snow. You know, the car, the traction control software, and the tires. All three of these components need to be finely tuned to do a job together. If one of those elements goes off, you're probably going to end up in a ditch and driving a rental car while your car is in the shop getting fixed. Same kind of theory goes forth with the tools, the cam software, and the mill. All three of those components need to be finely tuned to work together to get the best possible high performance out of the equipment that you can. So we just wanted to bring it in and kind of put it in a perspective for everybody there, to think about why we would want to do that and bring all of those components together for you. So at this point, I want to open it up to any questions anybody has. Anything we covered or didn't cover, if you have a question, go ahead and bring it up at this time and we'll be happy to try and answer it for you. And then we have one final thing we want to mention afterwards.
Mike, I do have a couple of questions. Thank you so much for your presentation, by the way. The first being, is there any special licensing for the software?
Special licensing. So the way the software works, our dental cam software, the license for the dental cam software comes with the purchase of the mill. There's no additional cost for that, and we have no annual fees. So if that's what we're referring to, when you purchase the mill, you don't have to worry about, oh no, now I got to pay for the cam software. Now I'm going to have a $1,500 yearly. No, it's one price. The mill comes with the cam software included in the price and no annual fees. Excellent.
The next is, do updates have to be manually installed for the software?
Updates, the software will let you know if an update is available and you can choose to download it and install it. The new Dental Cam 8 should have an auto installer built in. So if you choose to do that, it should add that into it for you.
Okay.
But you can simply run it. It's a very easy process.
And the next is, are the tools interchangeable? Do I have to use VHF tools?
That's a good question. So as we were mentioning, you know, we write our systems and our strategies for our tools. During the warranty period, yes, we really, really, really want you to use our tools. After the warranty period, you can do whatever you want. Running third-party tools, as you saw, could actually cause damage to your tools or possibly even the mill. Again, you change a tool, you need to be able to go in and change the toolpath strategies. Our toolpath strategies are not editable. They're proven, they're tested. Again, our system is designed to be able to give you speed and nesting and reliability. You could put one in there, but if something happens, it could compromise your warranty on the mill. So during the warranty period, we recommend you stay with the VHF tools. Outside of that time, it's your mill at that point. I guess you could do whatever you want with it. If you're using a different cam software that allows you to adjust those things with the mill, again, you still want to be careful because now you're opening it up for chances of different things that can happen.
And our last question that I have so far is, are the spindles covered under the warranty?
Spindles are an interesting topic. You know, we have a limited warranty on our mills. We like to say that there are things that are not covered. Kind of think about like a car. There's wear items. Wear items on our mill would be things like in the tool magazines, there's little rubbers that holds the tools that wear out over time. Obviously, those wouldn't be covered by warranty. Filters, things like that in the water tanks. But we also have, you know, where if something is caused due to improper use or improper maintenance, things like that, the warranty is taken on a case-by-case basis. So a spindle would be covered, but the bearings in the spindle would be considered a wear item. So if you're taking care of your machine, doing your proper spindle maintenance, that spindle should last you thousands of hours. I mean, seeing a spindle die prematurely is very rare. And if it does, we take it on a case-by-case basis. You know, there's always that, you know, good faith coverage if it's really early on. But again, we over engineer our spindles, and we never push them to the max. So we're not running them to where they should cause failure. So as long as you're, using them properly, not abusing your machines, doing your weekly collet maintenance, which takes just literally 2 or 3 minutes to do, those spindles should last you a really long time. But if they do fail, we take those on a case-by-case basis and have to look into see what caused the failure at that point. The machines do have a 24-month or 2,000-hour warranty on them as well.
Excellent. Robert has a question saying that he is a one-man lab and have run a K5 plus for the last 5 years, averaging about 50 zirconium mills per week. How often should he have it professionally serviced?
That's a really good question, Robert. So you've had the mill for about 5 years. If you've had it that long, it probably wouldn't be a bad idea to see about getting it sent in for a professional service and cleaning, and keep it running good for a long time. We recommend about every 2 years, about the length of the warranty. At that point, it's not a bad idea to send it in just before the warranty is getting ready to expire. Get it checked out, get it professionally cleaned, get it looked at, get it, see anything, that way everybody's able to determine, okay, these are things that could be coming up in the future that we see as an issue, or you might want to take care of these right now before your warranty expires. That's a great time to do it, at the 2-year mark, just before that warranty goes up. Get it in, get it a good professional servicing and cleaning, and protect your investment. 5 years, if you haven't got it done, if the machine's running great, that's it's up to you, but that would be a great time to send it in and get that taken care of. It sounds like it could last a lot longer for you, but as you can see, if you've been running that long with no issues, that's great. It's awesome to hear.
Yeah, I want to thank everybody for their excellent questions. And of course, Michael, thank you so much for your expertise on these VHF mills. I want to talk to you a little bit about relying on us to be able to get these highly reliable, precise VHF mills into your laboratory. And we can do this quite easily with our new Route 66 financing program. In a nutshell, this program does not, you do not need to send any payments in for the first 6 months, and that would mean no payments until 2023. So we're making it quite easy for you, like I said, to get a VHF mill or any piece of equipment that you've been dreaming about to take your lab to the next level into your laboratory. If you have any questions on this, please give a call to your Zahn representative, and they will get you over to someone in our financial department to speak to you about taking advantage, again, of Route 66, our new financing program. I'd like to thank everybody today for joining us here at Zahn Academy. And again, a special thank you to Michael for spending the time to give us this great presentation on VHF mills. Thanks again, Michael.
Thank you. I would thank Zahn as well for having us and letting us present to everybody. And thanks to everybody that took the time to attend today.